Okay, here I've got a skip being dragged along by a van, but I've got other stuff going on in this question. For example, I've got a coefficient of friction. Okay. I actually got an acceleration before I start. So this isn't one of the classic solve to find the acceleration. And in fact, the acceleration is going to be my starting point because we want to find the speed of the van and the skip when they have moved 6 meters. So, I have got to find, I've got a distance, I've got an acceleration. Now I need one more thing to use SUVAT. Okay. Do they start from rest? Okay. Is at rest. Okay. So I've got an initial speed of 0. I've got an acceleration. I've got a 6 meters. So I'm going to set up my SUVAT. So at rest is u equals 0. And acceleration 0.05. And distance they've got to travel is 6 meters. Okay. Oh, I should have mentioned, this is the June 2014 paper. That's where I've got this one from. Okay. What do I want to find? I want to find the speed. So I'm after what v equals. Okay. So from these three things, I could use s equals ut plus half at squared, solve a quadratic to get t, but it's to find v directly, it's more convenient to use v squared equals u squared plus 2as, okay? This is the one that doesn't work with vectors, but these aren't vectors, so this is good. So v squared equals u squared, which is 0, plus 2 times 0.05 times 6, okay? And you square root that to get v equals 0.775 meters per second. Okay, that was part A. All right. On to part B, which asks me to, well, let's take B and C together. We've got to draw a diagram showing the forces acting on the skip. We've got to draw a diagram to show the forces acting on the van, and then we've got this advantage bit. Let's do the forces first. Okay. So working from this diagram, I need to draw separate diagrams. Force on the skip, well, there's always a weight. Okay. Now, what's touching it? The ground's touching it, so the ground can exert an upward force at right angles to the surface. The surface is rough, so I can have a backwards force. Okay. So that will be a frictional force. This will be a reaction force. This will be a weight. And also the rope is pulling it forward, so there's a tension in the rope. So those are my forces on my skip. And when I do it for the van's got a weight. Okay. All right. I might as well quantify actually these. So the weight here is 800 G for that one. And the van is 1700 G for that one. And the van will have its normal reaction force. Okay, I could call this one R1 and call this one R2 because they won't be the same. The van has got a backwards force T acting on it, and there's also a driving force P acting on the van. Okay, and in both cases we were told to ignore any resistances acting on the skip or on the van. Okay. If you're wondering about friction for the van, actually it's friction that's being used to create this driving force, okay? Distinguish between friction and resistance. We're told there's no resistance on the van, so we've got all the forces we need. Okay, so here are the diagrams that I present in my solutions, and notice I've modelled the two things as particles. And we were asked why there's an advantage to doing that for the van. Well, let's actually look at the original diagram. Okay, I put the forces on, but actually if I was doing this for the entire van, not just considering it to be a particle, then this reaction force I've got acting up, I'm just assuming there's one force up from the ground. But actually the van, if I don't take it as a particle, it's got wheels in different places. So there are two different, in fact there might be 4 different reaction forces, one for each wheel. Okay, if I model it as a particle, there's just one force acting upwards, and I've simplified the situation. So as well as my diagram, I record my reason, my advantage of modelling the van as a particle. It means we only need to consider one reaction force, not one for each wheel. And I need to have read the question carefully. Let's just go back. Yes, it said when considering the vertical forces. So that was maybe the clue that I should talk about normal reaction forces. Okay, I have talked about vertical forces, so I have done C correctly. Okay, now we've got to find the magnitude of the frictional force acting on the skip. Now what do I know about friction? Well, I've got my force diagrams. That will tell me one thing. Okay, or will it? My force diagram, well, horizontally I can't relate F to T yet because that's going to be related to the acceleration. That's going to come later. I don't know T, so that doesn't help me find F. Okay, but vertically I can find R1. Will that help find friction? Yes, because the skip is slipping. If it's slipping, then F will equal F max, and F max is related to the reaction force. So that's my plan, okay? So my first thing to do is to find the reaction force. Well, vertical forces are going to cancel out. I could do a full-blown 4-vector F equals ma here, but I think this is one case where it helps to look at the vertical ones separately. So that's what I'm going to do. So there we go, the vertical forces. There's no acceleration vertically, so these two are equal. Okay, so R1 equals 800g, then I use F max equals mu R, okay, so R is going to be that R1 of course, and mu, it tells me what mu is in the question. Where was it? So it tells me the coefficient of friction, it's up here, coefficient of friction is 0.4, so mu is 0.4, so this is 0.4 times 800 G, and 800 G is 800 times 9.8, so 0.4 times 800 times 9.8, calculator says that's 3136 newtons, which you can round to 3140 if you want to, okay? You don't get penalised for too many significant figures, only too few, unless they specify a number. So I've got the frictional force on the skip. We've got to get the tension in the rope next. Okay, so now finally I'm going to be using F equals ma. And the first thing I'm going to use F equals ma for is the skip and then the van. But actually, on these, you just know you're going to be doing both. So it's not wrong to set them both up now. So F equals ma for the skip and the van. I've got the force diagrams here. So for the van, we're going to get... for F, we're going to have the acceleration is this way. Take that to be positive. So the F is going to be P minus T. That equals ma for the van. So there we go. P here minus T here equals the mass, which is 1700 times A. So that's F equals ma for the van. If I do the same thing for the skip's got a mass of only 800, so it's going to be 800A. Let's look at the force diagram. Okay. The horizontal forces now, I've got a forward T and a backwards F. It's also accelerating A this way, so that's my positive direction. So my F, my resultant force, I need to take as T minus F. Okay, so T minus F equals 800A. Now I've been very naughty in this question. I've talked about F equals ma, and I've used F for friction. So this should be resultant force RF equals ma. Okay, that's better. So, all right, I've got two simultaneous equations here, okay, but actually, I know what acceleration is. I know that the acceleration is 0.05. So I've deliberately set up both equations when I didn't actually need to, because that's kind of what your standard method of doing this is. If they tell you the acceleration, it's not a simultaneous equations. We can just find out what t is, because look, we found f, okay? So we've got t minus 3136 equals 800 times the acceleration of 0.05, okay, which gives us t equals 3136 plus, what's that, 4? No, 40. So that equals 3176 newtons, okay, and finally part F of the question. What does part F of the question ask for? It says find P. Okay, well, I've already done a lot of the work for this. Okay, part F. All right, I've written down RF equals MA for the van, and I'm finding this P. Okay, so if you find yourself having answered a question, either wholly or partly, okay, it doesn't matter, but when you write down part F, alert the examiner to what you've done. So if you say from above, okay, P minus T equals 1700A. If you'd completely solved this and found P already, you just say from above and you write out the answer again, so the examiner can follow what you're doing. So in this particular case, I've got to do P equals 1700 times the A, which is 0.05, and I must have added T to both sides, so T was 3176. So I need to do that calculation on my calculator, and it comes out to 3261 newtons. Double underline it. Okay, and that is the end. I am done.